Hey, everybody. Thank you so much again for setting aside some time with your Tuesday evening to join us in talking about battery energy storage systems this evening. My name is Ian Latimer. I'm a project manager with NYSERDA's Clean Energy Siting team. And just a couple of housekeeping considerations before we go ahead and kick off this evening's webinar. All of the attendees are in listen-only mode, so mics and cameras have been turned off. If you have any questions or concerns throughout the webinar, please make use of the WebEx chat feature. You can find that by clicking on the little chat box icon on your screen. Maybe take a moment to locate that just in case questions come up throughout the webinar. If you have a question referencing a specific slide, for our convenience, please do include the slide numbers so that we can go ahead and answer your question once we circle back to the Q&A. We will be doing a Q&A at the end of the presentation. We will be recording this webinar, which is why we're going to be saving the questions for the end. But again, we will do our best to address all the questions that get brought up throughout the event. And we will do our best to make this recording available in the near future on the Clean Energy Siting webpage on NYSERDA's website. We will make that available later on in the webinar as well. If you're having any type of technical issues or questions, again, please feel free to utilize that chat box. I will do my best to assist. And then finally, I do want to be clear, this webinar is not eligible for in-service training credits from the Department of State Division of Building Standards and Codes, although we do offer a similar course in person, which is eligible for the 2 hours of in-service credit. Again, due to the circumstances, we are presenting this as a webinar and it is not eligible for the in-service training credit. However, we will be emailing attendance certificates for the webinar out after the fact, and those may be eligible for professional development elective credits. A lot of you may be familiar with the elective credits form that you need to fill out. So you'll want to go ahead and do that with the attendance sheet that we will send out later. So I will go ahead and get started. Jen, if you wouldn't mind advancing the slide, I'm going to just provide a quick overview of what tonight's presentation will consist of. So again, we'll do a brief introduction of the two presenters that will be walking us through the presentation this evening, as well as an overview of New York State's ambitious climate goals and how battery energy storage systems fit into that. We'll go ahead and provide a quick overview of battery energy storage system technologies. We'll go ahead and then walk through the New York State Uniform Fire Prevention and Building Code requirements for battery energy storage systems. And then finally, we'll go ahead and talk about incident management for situations involving battery energy storage systems. And then after that, we'll go ahead and go to the Q&A using the questions that have come up throughout the webinar this evening. Now, go ahead, Jen. So I keep referencing Jen. That would be Jennifer Manier, my colleague on the Clean Energy Siting team. Jen's going to be taking us through the first half of tonight's webinar. Jen is a senior project manager on NYSERDA's Clean Energy Siting team, where she helps guide local government officials through best practices, appropriate local laws, and permitting procedures for solar and battery energy storage installations. Jen Manier received her BA from Hamilton College with a concentration in geology and a minor in economics. She also holds master's degrees in education from Elmira College and in ecological economics, values, and policy from Rensselaer Polytechnic. Our other presenter tonight, joining us from his company PGR Group LLC, we've got Paul Rogers. Paul is a retired FDNY lieutenant with over 25 years of experience. As an FDNY officer, Lieutenant Rogers was the fire prevention subject matter expert for the FDNY Special Operations Command Hazardous Materials Division. And as an SME, Lieutenant Rogers has collaborated with a number of agencies, including NFPA, UL, Con Edison, FM Global, Department of Education, EPA, Department of Transportation, and other regulatory entities. Lieutenant Rogers currently sits on the NFPA 855 Energy Storage Systems Installation Standard Committee and is a member of the International Fire Code Action Committee for Energy Storage System Installations. So with that, I will go ahead and turn the webinar over to Jen Manier, who's going to go ahead and kick things off. Again, if you have any questions, please do feel free to drop those in the comments, and my colleague Candace Rossi of the Clean Energy Siting team and I will go ahead and do our best to address those at the end of the webinar. Jen, are you here?
Absolutely. I assume you hear me.
Yep, I can hear you fine.
All right, great. So I'm going to try to get through my section as fast as possible so we can all get to the good stuff, which I think is the incident response section with Paul. But there's also a lot of good information in here about what's going on in New York and some relatively recent updates to the Uniform Code like Ian outlined. So as a lot of you know, New York has some pretty ambitious goals right now. We're aiming to have a carbon-free electric system by 2040. And to get there, NYSERDA is putting a lot of funding into renewables and with all of those coming online, we're going to need complementary energy storage to keep it going. Having some slide transition issues. So accordingly, with all of that renewable energy coming online, we also have some of the, if not the largest storage targets in the country. We're looking to get 1,500 megawatts of storage online by 2025 and 3,000 megawatts online by the year 2030. So just to put that in perspective a little bit, 3,000 megawatts of energy storage is the equivalent of about 40% of demand in all the homes in New York State. To help make that happen, we put $400 million in incentives out there. That includes retail incentives, bulk incentives, and also technical assistance, which is part of what you're experiencing here right now, tonight. As far as our team is concerned, if you haven't heard of NYSERDA's Clean Energy Siting team, it was formed maybe 2 to 3 years ago, and our first product was the Solar Guidebook, which many of you have probably seen. It's rather large. It's grown over the years. It includes a wealth of information. So if you are representing a local government and you have not seen the Solar Guidebook, I highly recommend checking it out. It includes information on, and we can also provide direct technical assistance with property taxes and negotiating pilots. We can help walk communities through the seeker process or adopting zoning laws. There's a model law in the guidebook that can be customized as you see fit. We also have guidance materials and technical assistance for municipalities interested in procuring their own renewable energy. And then finally, guidance for adopting and implementing New York State's Unified Solar Permit and also our slightly newer energy storage permit. And those are really streamlined processes for permitting smaller systems for both technologies. Following the Solar Guidebook, I think everyone loved it so much that we decided to go ahead and develop an energy storage guidebook as well. You'll notice, well, maybe not notice here, but it's quite a bit smaller. We only have 4 chapters at the moment. We're hoping to continue adding to this as more questions get brought up and we learn more about these technologies. But right now, it includes a model law for energy storage, which is formatted pretty similarly to the model law we have for solar. And again, that energy storage model permit we have that's intended to streamline permitting for those smaller systems. It also includes an electrical inspection checklist. And right now, Chapter 4 is the 2019 Energy Storage System Supplement, but we're hoping to replace that soon with a copy of the fully implemented 2020 codes. And I'll talk a lot more about that stuff later. So all of these resources that I just mentioned are available on our website. You can see the URL in the bottom left-hand corner there. You can also find us pretty easily by just Googling Clean Energy Siting NYSERDA. There are PDFs available of both guidebooks. All of the individual chapters are available for download. And any of the documents that you might want to edit, like the model law, are also available in Word format for you. And our contact information is located on there as well. So to get into a little bit of a high-level overview about battery energy storage technology, we know that these are going to be necessary for New York State to meet our current clean energy goals. Renewable energy is an intermittent resource, which means it's not always producing energy at the exact moment it's needed. And battery storage will also help make the grid more reliable. So this diagram here is just sort of an example of what the grid of the future might look like with renewable energy sources charging energy storage or batteries that can then provide energy to homes and buildings, provide grid services, which I'll talk about a little bit more soon. And as far as energy storage system types go, there are 5 overarching buckets of energy storage technology types. There's pumped hydro, which many of you are likely familiar with, which is like pumping water into an elevated reservoir when electricity prices are low and then releasing it to spin turbines and generate electricity when demand is high. So that's sort of one example that's been around for a while. There are mechanical storage technologies like flywheels and compressed air. We're not going to go into most of these because we're really trying to concentrate on electrochemical storage, which is what you would typically think of when you're talking about a battery. you know, what powers your laptops, your cell phones, your electric cars, and so on. All of these batteries that we're going to be talking about have three major components: an anode, a cathode, and an electrolyte, which is the electrolyte's really just a medium to allow current to go back and forth between the anode and the cathode. Charging and discharging the batteries just reverses that flow. And these can be made up of a wide array of different chemistries, which will determine how the batteries perform. And depending on that chemistry, the batteries may be more efficient, more or less expensive to build and operate, larger or smaller, and be able to produce electricity for varying periods of time. So depending on the application, different battery chemistries might be preferred. Lithium-ion batteries, like you see in your phones and laptops and electric vehicles, are currently the most popular and likely to be widely deployed. They have, as this chart shows in the last column there, a high energy density compared to other types, and they're also widely commercially available. And while not shown on this chart, different chemistries also present different safety considerations, and that's a lot about what we'll be going through soon. All right, so every energy storage system is usually going to consist of at least these three components. The first, over on the left-hand side, is the cell that's considered the building block of the system. They tend to be smaller. They might range in size from something akin to a AA battery or what's in your cell phone to perhaps maybe even the size of a small tablet. Next component is the module, which just really consists of multiple cells that are wired together. And then when multiple modules are wired together, that creates what we refer to as a battery rack. And importantly, all of the energy storage systems we'll talk about will also have a battery management system. This is basically the brain of the whole energy storage system. It notifies about issues outside of normal cell, module, or rack operating characteristics, and it will do things like trigger cooling systems and ventilation and sound alarms if anything like that does happen. So a little bit more detail on why we're even doing this. So most people are familiar with storage as a backup system in the event of a power failure, and that is certainly one usage, but it also has a ton of other relatively largely untapped potential to do things like reduce peak load, provide frequency regulation to protect critical equipment, and probably most importantly for our purposes, make it feasible for the grid to accommodate all the new renewable energy that's coming online. Like I said before, we all know that solar and wind are intermittent power supplies, not always generating electricity when we need it, so storage can help solve that problem. You might also see energy storage serving an individual home or a commercial building, but the big game changer is probably going to be grid scale, utility scale energy storage. When serving an individual facility or building, for example, energy storage can provide that critical backup power and may even help reduce peak demand charges on the electricity bill for that building by providing on-site power when perhaps grid energy is more expensive. On the utility or grid side of things, energy storage can provide frequency regulation to keep the grid functioning at its best. It can serve as a source of electricity when generation sources are not available or some of them might be more expensive. And like I said before, it can help meet peak demand even for the grid, that time of day when demand for energy from the grid is at its highest. So think like a hot summer, late afternoon with air conditioners running at full blast in office buildings and homes all across the state. Typically, this additional electricity demand has been met with what we refer to as peaker plants. And also historically, these peakers have been fueled by gas. Energy storage, battery energy storage in particular, has the ability to replace gas peakers with a much higher range of capacity. They can provide simultaneous grid services while old peaker plants are generally slower to respond. In fact, we have one in New York that I'd like to point out So I know Ravenwood Development is approved and is planning to build a 316 megawatt system down by New York City. And the first phase of that, 129 megawatts, is expected to be completed by March of 2021. So we're already sort of seeing this transition from gas peakers to energy storage. And if you notice on this slide, the range for energy storage is listed at 200%, and that's because they have the benefit of both being able to provide electricity into the grid, and they also have the ability to take electricity out of the grid when it's not needed and beneficial. So that's where we get to that 200% there. So, of course, any technology is going to come with its own risks. The biggest concern you've probably heard with energy storage and lithium-ion systems in particular is fire. Lithium-ion batteries, after experiencing abuse of some sort, be it overcharging, physical damage like puncture or crushing, or exposure to extreme heat, they can experience a process referred to as thermal runaway. Essentially, once one of these batteries is compromised, it can begin to overheat, changing the dynamics inside the battery, causing further heating. It's like a positively reinforcing process, and we refer to this as thermal runaway. And once it's happening, it's really difficult to stop it. So, and also as part of this process, when their batteries are overheating, they can also begin to off-gas potentially explosive gases. So if those gases are allowed to accumulate in a space, they can present an explosion hazard. And so we're going to spend the rest of the time discussing what is being done to mitigate these risks, both through prevention with stringent appropriate codes, and also through smart, informed incident response procedures. So, and this is in reference to that chapter 4 of the guidebook that I was talking about earlier. I promised I would talk about it a little bit more, and here we are. So last year, the New York State Uniform Code was amended effective July 1, 2019 via the 2019 Energy Storage Supplement, and that was to incorporate updated energy storage fire safety requirements that were modeled after the draft 2021 International Fire Code, which is the best there is at this time, especially as it pertains to energy storage systems. The New York State Uniform Code is the law statewide outside of New York City, which has its own codes. More recent changes introduced in 2019 that I'm talking about here were actually fully implemented this year in the 2020 New York State Uniform Code, which goes into effect this May. But note that the newly adopted 2020 code, as far as energy storage is concerned, is pretty much most of the same requirements that were in that 2019 Energy Storage System Supplement. And I think it's also nice to notice that New York State takes this very seriously, and as far as I know right now, New York has the most stringent fire code in the country for battery energy storage systems. So we can be resting assured knowing that. This presentation is going to cover the newer requirements at a high level, but disclaimer, we are not going to convey every detail and nuance. We would probably be on here for hours and put everyone to sleep. So just make sure that you always refer to the Uniform Code for complete requirements, and you can find it via the link that you see here in the upper right-hand corner, and I've highlighted one of the main sections that we're going to be talking about, which is the fire code. All right, so most of what we'll be talking about today are the code requirements for systems that are not subject to the residential codes and that exceed the capacities outlined in the new fire code as shown on this slide. These will encompass the majority of commercial and utility-sized installations, and most of the upcoming slides are going to be pointing out code requirements for these. We'll take a few minutes right before, about an hour in, to go through a little bit of the residential requirements as well, but for the most part, we're focusing on these larger systems subject to the fire code. So one of the first things you'll see in the new code is the hazard mitigation analysis. And this is only required for systems that are over 600 kilowatt hours, so your larger commercial systems. And this study is done to evaluate the consequences of different failure modes. If this, then what? And these are usually done by an engineering firm or the authority having jurisdiction, the town, whoever's permitting it, to determine the best approach on how to handle the failure should it occur. On top of that, where required throughout the code, it's kind of sprinkled throughout, large-scale fire testing must be conducted on a representative energy storage system in accordance with UL 9540A, which is really just a testing protocol, or an approved equivalent by an approved testing laboratory. And the point of this test is that would need to show that a fire involving one system will not propagate to an adjacent system. It should also show that if a fire does occur, it will be contained within the area for the duration of the fire resistance rating of the room assemblies where it's located. That test report would be provided to the fire code official for review and approval. And there are a few requirements throughout the code that can be altered or perhaps been made a little bit less stringent based on the results of this large-scale fire testing. One great thing, I think, anyway, about the new code is the fire remediation team, which is paid for by the owner of the energy storage system. This requirement was put into place to alleviate the fire service of potentially babysitting an energy storage system after a fire or an emergency event took place. These systems are known to reignite sometimes after extinguishment, and the fire service did not want to put a company out of service to sit there and watch these systems and make sure they don't catch fire again. So in these cases, a fire remediation company will be called to the scene to relieve the fire department and start the decommissioning process. Another great perk, I think, for authorities having jurisdiction is peer review. And because this is an emerging technology, it's not anticipated that every town, city, village, county in New York will have the technical skills to assess the applications that come in. So the peer review will allow a third-party expert to come in and assist the authority having jurisdiction to ensure that the project is installed safely to code. If the scope of work that the AHJ needs is limited or focused in an area that does not require the services of a registered design professional, a special expert can be used, and that's defined here in the fourth bullet on that side. So this is no surprise, like many other types of systems, commissioning needs to take place to ensure that energy storage systems will perform as they're intended to. And it's required prior to the system being placed in service. The plan needs to be approved prior to starting commissioning, and the report needs to be approved prior to final inspection. The commissioning plan would include a narrative description of the activities that will be accomplished during each phase of commissioning, including who would be doing what. An operation and maintenance manual must also be provided to both the system owner or their authorized agent and to the system operator before it's put into operation. And the system needs to be operated and maintained in accordance with the manual, and a copy of the manual needs to be retained at an on-site location and include testing schedules and, more importantly, even logs of when testing was done throughout. Then finally, a decommissioning plan needs to be submitted actually as part of the commissioning plan that we were just talking about. And the authority having jurisdiction must be notified prior to system decommissioning. The plan would include details on providing a safe and orderly shutdown. It includes a narrative of the activities that would be accomplished while removing the system from service, and a listing of any contingencies for removing an intact operational system from service and for removing a system that's been damaged by a fire or other event. And to further safeguard against some of those hazards that I mentioned earlier, systems must also all be listed in accordance with UL 9540, which is the standard for energy storage systems and equipment. Chargers, inverters, and battery management systems, if they're not already covered as part of that system UL 9540 listing, they can be listed separately. And it's important to note that if systems are repaired with anything other than identical parts, it'll be considered a retrofit, subject to a permit application and most of the same requirements as a new system. And we touched on this briefly earlier, but the battery management system is really an instrumental safety feature for energy storage. You can think of it as the eyes and ears, maybe even the brains of the battery system's health. It's constantly monitoring the state of health of the energy storage system and responding accordingly. For example, it might detect an individual cell overheating and shut it down and isolate it from others to prevent thermal runaway from occurring. So you can imagine if the battery management system were to fail, the system would lose a major safety feature, which is why those UL listings, test protocols, and commissioning are so important. This one might seem a little obvious to most of you, but all energy storage systems should be made of non-combustible material. This is to contain the fire within the enclosure so the heat doesn't transfer to other, perhaps nearby enclosures. Electrical disconnects are also extremely important to first responders, and they should be in a secure location with signage to direct the first responders to the proper place. One important point to remember is that even though you may shut down the energy storage system, the stored energy inside the batteries does not necessarily dissipate. It's their job to hold on to it. So I don't want to preempt a lot of the things that Paul is going to be talking about in the second half of this, so I will just leave it at that and let him get into some more fine-tuned details about what to do and which buttons to push and when it might be safe or not to actually hit the emergency shutdown. All right, so getting into some of the other general installation requirements for battery energy storage systems. And so lithium-ion batteries, which I've mentioned are likely to be the predominant type we're seeing, they don't release any toxic gases during normal operations, so it's not required for them to ventilate. Some other types of batteries do release toxic gases during normal charging and discharging, and those will need some sort of hazardous exhaust system included. Signage is also required for every system. It's necessary to let people know there are batteries in the location, what type of batteries there are, that they're energized, and perhaps most importantly, emergency contact information in case of an incident. Similarly, fencing, this might also seem obvious, but fencing is required to prevent unauthorized people from entering the area. There's a lot of stored energy, of course, inside that could injure people when they come in contact with the system if they don't know what they're doing, so security fences are a must. Outdoor walk-in units, we'll talk about these, I think, a few different times today, but these are defined as an enclosure that is not for human occupancy, but it can be entered for maintenance, replacement, repairs, and inspection. The risk of these containers presenting a life hazard inside during an event is significantly less than with systems that might be located indoors, especially when compared to buildings that are only being used for battery energy storage. So unless there's reason to believe that someone is inside one of these, the advice is to stay out and respawn from the outside, because odds are there's no one in there the vast majority of the time. All right, so we're going to get into some more of the specific requirements. And these are based on the type of system that we're talking about and also the location of the system, which we'll get into in a little bit. So first, we have a size and separation requirement. Grouping of energy storage systems to a maximum of 50 kilowatt hours is there to reduce the fire load of any one group or rack. This grouping does not apply to remote outdoor installations. We'll see that a little bit later. It does, however, apply to walk-in containers or cabinets that are outdoor and near other exposures. And walk-in units that are near exposures, while they do need the spacing between the groups inside, they do not need spacing between a group and the wall of the walk-in unit. There are 2 exceptions to this requirement, and you'll sort of see this on a lot of the slides coming up where we have a big red box showing where the exceptions are. So one is for communication utilities, and the other is based on that large-scale fire testing. If the test report shows that it's not a concern, you may be able to get that 3-foot distance to something less, so you can fit more. Okay, so this slide here represents the maximum allowable quantities of batteries that can be installed in any given area. And if an installer wants to exceed the values listed in the table, it is possible, but they'll have to go through the hazard mitigation analysis and also that large-scale fire testing that keeps coming up to ensure that the system will be safe. And once again here, there are some other exceptions. Lead acid or nickel cadmium batteries under the control of communications utilities and also dedicated use buildings are exempt from this requirement. So generally speaking, you want the fire department to have easy access to respond to an incident. Therefore, these systems cannot be located more than 75 feet above the access point or below the lowest exit floor. However, like many other requirements, fire department officials have the right to permit higher or lower, but only if they feel comfortable with the safety features and the fire protection systems that were installed. It's also important to note on this slide that rooftops are treated a bit differently and they have their own set of requirements, and we will go through those in a little bit. When systems are inside a controlled room or enclosure, the smoke alarm is generally the easiest way to sense a fire. When not possible, radiant energy sensing systems can check for excess heat. And if there's a temperature rise, they can send a signal to an alarm panel that will notify the fire department that there's a problem. Central or remote monitoring stations are used to monitor the systems and any alarms. It's important that these are in a safe location, away from any potential hazards, and constantly manned. Fire suppression systems. So although the code calls out this water density, which is 0.3 gallons per minute per square foot, it may be a challenge to get that much water to the upper floors of a high-rise or in an area that does not have good water pressure. In outdoor locations, some AHJs are using a dry pipe that the fire department pumper would be supplying the water to. And this is used so that automatic water suppression systems don't accidentally freeze or malfunction and cause the water to flow on a system that perhaps had no problem. So there are some options here. And on top of that, you'll see that instead of water, you can use other approved non-water extinguishing methods that are listed out on number 2 on this slide. So some of these containers may end up with 2 types of suppression. A clean agent, like a gas of some sort, that might act as a first-line response, and they may also be equipped with water fire suppression. Water should only be placed on these systems when there is a known fire event, if necessary, because it will ruin the batteries permanently. I touched on these outdoor walk-in units a little bit before, but they also have volume limitations. They cannot exceed 4,028 cubic feet, and the dimensions you see above it are like a rough estimate of what that might look like. Any container that's larger than this would cause the system to be treated as an indoor installation, which would have stricter requirements. And as the energy density of batteries continues to go up as the technology evolves, first responders should be aware that a lot of energy would be stored inside one of these containers. For outdoor systems, a 10-foot distance is needed for all vegetation, from all vegetation except ground cover, like something like grass or ivy is fine, but other than that, the system should be placed 10 feet away from anything else that could potentially catch fire. And this is another one of those requirements where the clearance of 10 feet can possibly be reduced based on that large-scale fire testing. Okay, so we just covered a lot of requirements for some commercial system. Most of these are put in place to prevent thermal runaway. And now we're going to talk about different requirements necessary based on different battery technologies. They're not all created equal, and the different chemistries lead to different compliance that's required to maintain safety. So this table here is showing an example of the types of charts you'll see in the code. This one lists out the battery technology and shows which protections are needed for specific chemistry types. As they differ, there are different requirements for each chemistry based on the types of hazards they might cause. I'll reiterate again that in New York, we anticipate the market will utilize mostly lithium-ion batteries, at least in the foreseeable future. So if you look at the lithium-ion column, you'll notice it doesn't require exhaust ventilation, for example, because they don't emit hazardous fumes when they're charging or discharging over the normal course of operations, but they do have the potential to emit flammable gases in the event of a fire. So you'll notice that they do have a yes for explosion control. So that's just one example of how requirements differ for the different technology types. And we'll discuss some of these in a little bit more detail on the following slides. So maybe not lithium ion, but some systems do need ventilation for a battery during the charging. Some may be releasing hydrogen as part of that. So in that case, the developer would need to install a ventilation fan, perhaps for a walk-in, with battery chemistries other than lithium ion. It could be used for lithium ion systems as a method of explosion control, and we'll talk about that in a couple of slides too. So as part of that exhaust ventilation requirement, a gas detection system would be required to monitor the levels of gas in the unit. This could also inform operators of unusual levels of off-gassing. Some battery energy storage systems use liquid electrolytes, which can be corrosive. They can burn the skin, damage first responders, PPE, and first responders should follow their department's standard operating procedures when responding to corrosive spills. Some of these chemistries can contain corrosives that are upwards of 1,000 gallons. These systems should have secondary containment, and in some cases may even have tertiary containment. Lithium-ion batteries do not fall into this category because they do not have liquid electrolyte. So as I touched on a little bit earlier, some system types, like lithium-ion, have the potential to release explosive gases when malfunctioning, overheating, etc. And this explosion can be handled in two ways, or explosion control can be handled in two ways, rather. Deflagration venting and deflagration prevention. So most lithium-ion systems will have deflagration venting panels that will manage the overpressure blast wave that's produced in an explosion. That blast wave will be sent through the venting panels and should maintain the integrity of the container. The panel's venting direction should be directed to an area that won't interfere with the fire department operations or otherwise hurt someone. And as discussed earlier, while not required for normal operations, exhaust ventilation can be used for lithium-ion systems as part of explosion prevention. Some battery types will also require safety caps. For example, hydrogen is a byproduct of the lead-acid battery charging and discharging process. So in addition to ventilation, safety caps are designed to open and release any gas buildup without allowing flames to enter the battery. And as I mentioned earlier, thermal runaway, once it's started, is very difficult, if not impossible, to stop within a cell. So energy storage systems should have a device that can recognize when the temperature is rising, and that device, the battery management system that we've talked about, should isolate that area and send a signal to the owner of the system that a problem exists. And testing has shown that stopping the charging and discharging of a cell is an effective measure to prevent the cell from even really going into full thermal runaway. And on the right side of the screen, it shows the stages of thermal runaway and how it can propagate to adjacent cells if it's left uncontrolled. So a method must be in place to prevent the cell from going into thermal runaway in the first place, and also to prevent the spread to adjacent cells. Okay, so to review a little bit, we've gone over requirements that all commercial and utility installations will need to meet, as well as some additional requirements based on their chemistry. So lastly, we'll go over different requirements that are needed based on where the system's located. This is an overview of how the code's broken up based on location. We have dedicated use buildings, which is what it sounds like. They're built just for housing battery energy storage, non-dedicated use buildings that might have more than one thing going on, outdoor systems that are near other exposures, and outdoor systems that are remote. This is an example of what a cutaway of a dedicated use building might look like. And again, these buildings are used for the sole purpose of housing an energy storage system. You can have admin personnel in there, but that area is only limited to 10% of the floor space, and they have to be blocked off by firewalls and have their own exits. And again, a non-dedicated use building would be anything that doesn't meet the specifications outlined here. And as you can imagine, the requirements for those two types of buildings differ. And here, another chart. This is a list of the compliance that indoor installations need to meet. We already reviewed the general installation requirements, the electrochemical protections, and the chemistry-specific protection. There are two additional requirements that are needed for indoor installations that we'll review on the next slide. However, note on this slide that dedicated use buildings have some exceptions on the smoke and automatic fire detection and fire suppression system requirements. And that's because they pose a significantly less threat to life safety if an incident were to occur. So some of those requirements can be waived by the fire code officials. Okay, so otherwise, the additional indoor requirements are that the energy storage system cannot be installed inside of a dwelling location. When an energy storage system fails, it may release toxic fumes that could be really bad for a human, possibly even kill them. And for those reasons alone, the risk is too great, so don't install them in sleeping units or habitable spaces. For any of them, 2-hour fire barriers are needed in a room or area. This includes the ceiling as well as the walls. So now moving on to outdoor installations specifically, like I said before, they're either defined as being remote or near exposures. A remote outdoor installation would have at least 100-foot clearance from buildings, lot lines, public ways, anything that it could potentially damage if an incident were to occur. And installations near exposures are less than 100 feet away, not remote, as described above. So, of course, remote systems will not have the same requirements as other outdoor systems, again, because they don't pose the same life safety risk factor involved, so their requirements are less stringent. Note the subscript on the suppression system line here, which is about halfway down the slide. The AHJ, the authority having jurisdiction, can allow the suppression system to be removed in this situation for remote installations. And again, that's due to the lower risk of actually hurting someone if an incident were to occur. So outdoor systems are typically housed in one of two ways: walk-in containers or cabinets. So this slide is showing an example of walk-in containers. And here you can see the maximum enclosure size we discussed earlier. They're about the size of a standard shipping container For a little bit of scale, if you can see on the left-hand middle-ish side of the screen where that first arrow is pointing, the two little green dots are actually people walking down the aisle. You can see the fence around it, how it's secured from outside access, and the aisles are nice and wide and provide an adequate means of egress. This here is an example of battery energy storage system cabinets that house batteries and can be installed outdoors. These are maybe somewhere in the ballpark of the size of a refrigerator. And this here is an example of an entire outdoor cabinet system. And this is kind of a nice example showing how the size and separation requirement that we talked about earlier is not required when a system is considered remote. There's definitely not 3 feet between each of those cabinets. Outdoor installations also need to be at least 10 feet from other structures or potential exposures as a fire barrier. The distance can be reduced by that large-scale fire testing, once again, or by placing a fire barrier between the energy storage system and the structure. And that fire barrier should be at least 1 hour rated. The second option is for the building that is adjacent to the system to be non-combustible and have a 2-hour fire rating with no openings or combustible overhangs. Energy storage units can be installed on building walls if they meet the requirements outlined on this slide for the max capacity of each unit at less than or equal to 20 kilowatt hours, the unit separation, and avoiding possible inlets like windows, doors, and of course otherwise meeting code requirements. I alluded to this earlier, but there are also special requirements for projects that are installed on rooftops or open parking garages. They have many of the same requirements we've seen for the other systems, with just a few caveats that I'll go through. These systems are required to have fire suppression inside the units and also on covered parking levels, but automatic fire suppression is not required for energy storage systems on the top level of the parking garage if there's no roof or ceiling, if it's open to the sky above. Rooftop installations, promised to bring this back up again earlier too. They should have a roof access point from inside the building for first responders to use. The roof should have a standpipe that the fire service can use to put water on the fire if necessary. And the system cannot be within 10 feet of the roof access. You want them to be able to get up there safely without running right into it. And it also needs to be at least 5 feet away from the roof edge. All of these distances are used to safeguard the fire department operations response. Also, systems that are on rooftops or in parking garages, they need to be at least 50 feet from air intakes. There's an exception to reduce that distance to 25 feet if there's a way for the fire detection system to automatically deactivate the ventilation if there's an incident. All right, so now we'll quickly go through some of the residential system requirements. They tend to be a little bit simpler and quicker to go through. So these are a couple photos just to give you context on what a residential system looks like. They might be the size of a suitcase, and most of them come pre-packaged. The residential threshold sizes shown on this slide are also outlined in the Uniform Code requirements. Residential systems can exceed these capacities to ensure that they're safe. So that's 40 kilowatt hours if they're located in utility closets or storage spaces, and 80 kilowatt hours if they're in the garage or anywhere outdoors. For residential systems, the individual units have a maximum capacity size of 20 kilowatt hours per unit. They also must be separated by 3 feet, both from each other, and any doors or windows if they're located on exterior walls. An average residential unit is usually around 12 to 16 kilowatt hours. And in the pictures here, notice the installations on the walls. The one that has an X through it is wrong because you cannot install an energy storage system in living spaces, if you recall from earlier. And of course, on the residential side, we also have fire rating requirements for walls and ceilings of rooms containing these systems. And that's to ensure that if there is an incident, the walls can resist spreading the fire. And finally, whenever these systems are located indoors, they need to have a fire alarm. Cabinets that are placed outdoors might not be able to meet the requirement of smoke detectors because the air moves it far away from it. So they could satisfy that requirement by using a heat detector. So that was very fast. I have no idea how many questions are in the chat box, but I hope there are some. I think, wow, I went way faster than I anticipated. We're already at the 5-minute break. And I don't know if we want to take that now or go right into Paul and have another 5-minute break later, but I will maybe let Paul decide that.
Hey, Jen.
There, Paul?
Yeah. Can you hear me? Everyone hear me?
Yep, we can hear you, Paul.
Yeah, it looks like a couple of people are just writing that they want us to keep going. So let's move on. How you doing?
All right,
everyone?
great.
Good job, Jennifer, by the way. Okay, so just a little bit about myself. As Ian had mentioned, I had worked on this with the New York City Fire Department. This was brand new when it came into our area. We weren't familiar with it, so we had a lot of questions. And one of the things that we realized is that there really had to be a connection between the people in the operations portion along with the people that were actually going to put these things in the installation. So the code officials for New York City Fire Department really did a great job working with the operations people. But I started to get into the codes very deeply on this, and currently I sit on the 855 in the International Fire Code Action Committee for this, Chapter 12, which if you're familiar with following IFC, you know there's a new chapter dedicated strictly to this particular sector right here. So next slide, please. So as I said, I was working from the response side, and one of the things that wasn't out there was how do we respond to these things and how do we detect the firefighters. A lot of people look at the codes and they say, okay, let's make sure that we detect the people, but what about the firefighters? And that was constantly thrown out there whenever we had people visit the New York City Fire Department for installations. So one of the things that we did is we wanted to look at all the failure modes of each individual chemistry, right? We wanted to know that how do these things fail and how is that going to affect the firefighters. So some of the failure modes that you see here on this slide is the overcharge, and we've seen that before on lead acid batteries. I've been to a couple of them in telecom communications or UPS systems. So usually if we shut them down, they should be all right. But that was a big one that we wanted to know a little bit about. Heat is another one. Heat is the Achilles heel for lithium ion. And most of the work that we talk about today really is dedicated toward the lithium ion sector because it really is kind of new in the application on how they're actually using it. So we really needed to get some information on that. Component failures is another thing. Responders are not familiar with these things, very technical subject. So they don't even know some of the components, but if there was a problem with the BMS, which was mentioned before, that could cause an overcharge or cause a heat or some other failure from taking place. So those components are, they have to be listed on some cases, like the inverters that she had mentioned before, Jennifer mentioned before about the different listings for the product itself. Environmental issues, what happens if this thing starts to get into the environment? What do we need to do on that situation? Impact and mechanical issues. What happens if there's a localized collapse and the building with a collapse on this thing, if it's inside the building? What happens if someone drove a car into one of these things? Don't laugh, it's happened. These things could, you know, I've seen so many things in my time on the New York City Fire Department where I'd say, wow, that wasn't supposed to happen. Sure enough, it wound up happening. Factory defects is another thing that could happen where we have no control over that. Maybe there was things that weren't made properly and sure enough could cause a fire. End of life. Some people like to push their systems a little bit too much. So they have a certain amount of cycles that they can go. If you go above those cycles, then you'll start to see some deterioration. We haven't seen that yet because this is brand new. But 5 to 10 years down the road, as we start to see these things get toward the end of life, I'm curious to know if we're going to see more failures. Hopefully we don't, but I'm just curious. The BMS should be able to pick that up where we shouldn't have it. There's a lot of safety features in there to actually make sure that doesn't take place. But as we get toward the end of life, I'm just curious to see what's going on. Lack of maintenance, when people are just putting these things in there and then really not maintaining them. And this is something that your fire department should have some sort of inspection on that to make sure that these things are being maintained properly. And also the installation work. And again, it all comes to who did they hire in order to put these things into the actual location where you're at, and how did the hookups go. So next slide, please. Okay, first we're going to talk about there were a couple of different chemistries. The first chemistry that we'd like to talk about is this lead acid chemistry or the nickel cad. They're kind of similar, but they're known to have their corrosive spills, and we usually see them in the UPS sector, as I mentioned before, in hospitals or in very critical areas where they need that backup energy. So these things are not new to us. They're probably already in your location all over the place, these lead acid batteries. So, and we've seen some spills, but lead acid, that's our biggest concern, is these spills. Sometimes when they do overcharge, they'll put out a little bit of a toxic gas, but the big problem that happens is the hydrogen. But when there is a hydrogen release on these things, they have that little exhaust fan, and Jennifer alluded to that earlier, that this is part of the requirements of having lead acid and nickel cad inside the building. You've got to have those exhaust fans, and they have to be monitored for the hydrogen. So if it reaches 25% of its LFL inside the room itself, those fans will kick on and pull that stuff out. One of the things that the responders that are on here should be aware of is if you happen to get a call for an overcharged battery and you get a CO detector reading on your CO meter, that is a cross sensitivity with the hydrogen. So just keep that in mind. I've had that on numerous occasions, wasn't sure about it, and then sure enough, we did some experimenting and we figured it out to be hydrogen is cross sensitivity with your CO detector. Explosions are always a concern. Whenever you have a hydrogen explosion, they're pretty nasty explosions. So making sure that everything is being pulled out of the system or pulled out of the room itself, the hydrogen, so we don't have any type of explosion. And during a shutdown, which Jennifer also mentioned before, we got to be concerned about arc flash. When we're shutting off a large amount of energy, we got to make sure that there's no arc flash by just shutting these things down. And there should be some sort of signage there for the firefighters just to warn them about some sort of arc flash that could take place. And then last but not least, the stranded energy. And when you shut them things down, firefighters think, okay, the power's off, we can actually do some work now. Well, that's not the case. That stranded energy is still there, similar to with your flashlight. You turn your flashlight on, the light goes on, but when you turn it off, that energy is still there in the battery itself, right? You didn't dissipate it. You can turn that thing on and off anytime. Next slide. All right, flow batteries. I'm just saying, can everyone hear me? I see someone who says here they lost the audio. I just happened to notice that. Hopefully everyone can.
I can still hear you, Paul.
Yeah, I can hear you, Paul. We're troubleshooting the audio, but I think that you're good.
Okay, great. So another type of battery that's out there is these flow batteries. And these flow batteries, from a firefighting point of view, they're not such a big concern for us. They're really, the chances of these things going on fire are very slim. They have two vessels that you see on the right and left side of the actual picture there, and they're full with nothing but corrosives. And that's our biggest concern. They may have a lot of corrosives. I was looking at one installation that was going on the setback of a 25-story building where they wanted to actually put these flow batteries with 1,600 gallons of sulfuric acid in the middle of Manhattan. Well, actually, it was downtown Manhattan. And that was a pretty hairy one. But we can talk about that later. That thing did not get approved and it did not go get installed. But our biggest concern with these things are the corrosives that are inside those vessels that you see, one marked in orange, the other one marked in blue, and they pump. there's a pumping action that takes place, and as a result of that pumping action, energy is created. But once you shut down that pumping action, then we can dissipate that energy, and that's the one good thing about flow batteries. We thought in New York City that these things would make a big splash, no pun intended, but really we didn't see too many of them. There is one that is up in Jacobi Hospital in the Bronx, and they have a lot of different things to make sure that the corrosive does not spill out. So there's secondary containment and also tertiary containment in those situations. If they do overcharge, though, they do release hydrogen. The nice part about this thing that was in the Bronx, any of that hydrogen was supposed to be pushed right outside the container itself, so it would never build up into the container. But they do still have hydrogen monitors inside the container or the enclosure itself to make sure that if this stuff does build up in there, it will send something to the fire department. Arc flashing is another thing, shutting these things down, large amount of energy. We got to be concerned about that. Wire degradation, and we'll see that with sometimes rodents. When these things are outdoors, rodents get in there and they actually start to chew away at the wires, or they'll actually degrade. Maybe some of this electrolyte may actually spill or drip onto some of the wiring, and that's a concern for us too. And again, stranded energy with this one is not as big as a deal. The moment you shut down that pumping action, that liquid goes back into its vessels, and the amount of stranded energy is reduced significantly as opposed to like a lead acid or lithium ion. Next slide, please. All right, now we get into the lithium ion and the failures that are involved with lithium ions. So thermal abuse, the Achilles heel, as I said before, for a lithium ion battery is heat, right? So thermal abuse is always a concern for us. If you have your regular phone and you leave it out in the sun, you can see what happens to your phone when you leave your phone out in the sun that has a lithium ion batteries. And we've all experienced it where the phone will actually give you a message, take it out of the heat source, and it will shut down so you can no longer operate. And that's supposed to happen with one of the safety features. But if it continues to go, you'll get a cell that will go into thermal runaway. The moment it goes into thermal runaway, you can't stop it. It just continues to go, and that heat will actually transfer to the adjacent cells. And it was a good visual that Jennifer presented, but that thermal runaway is a concern for us. Once we have that heat transferred to the next cells adjacent to it, then sure enough, those things go into a heat thermal runaway event, and then it continues to propagate throughout the module itself. And then we could have going from module to module, and that becomes a big problem for the fire service. Electrical abuse, overcharging and undercharging is always a concern there from all chemistries, not just the lithium ion, but all chemistries. Even the undercharge, when I first learned about the undercharge, I was kind of confused on that. But if you take a look at your phone again, when you do go down to zero, you still don't lose your contacts in your phone. You know why? Because there is still some charge left in there. That is just a safety feature on your phone to say, hey, you're not going any further than this. This is where we stop. And it shows zero on your phone, but there's still energy in that battery on your phone itself. Mechanical abuse, when the actual battery gets crushed, and we mentioned before about a collapse in a building or a car going through something, but when that gets crushed, there's a separator between the positive terminal and the negative terminal. And when they touch, just like your car battery, if you ever done that, where you touch the positive and the negative together, you get yourself a nice spark. Well, the same applies in this. Inside of those actual cells is this positive terminal, a negative terminal, and there's a separator to make sure that they don't touch. But if you compromise that separator, well, now you have that positive terminal and negative terminal actually touching. And then factory defects is always a concern. If they don't have good quality assurance, they can get stuff into the actual production of them, and they can puncture through the separator, and now you'll get an electrical internal short circuit on the inside. And different components, if the components are not made well, you can have a problem. But if I want you to take a look at the picture on the right-hand side. That's a picture of a plane that went on fire. These things are everywhere. Although we're talking about energy storage right now, these batteries are everywhere. They're in electric vehicles, they're in planes, they're in cargo of the planes, and anyone who's getting shipments of these batteries now, even if you get your phone shipped to you by mail, there's going to be some sort of labeling on there. People are looking at these things, these lithium-ion batteries, very differently now from the transportation side of it. Next slide, please. Thank you. So there was some preliminary testing data that was done by NYSERDA. They joined up with Con Edison, which is the local utility company that supplies electricity to most of New York City. And during this testing, they took a battery and they abused it. They abused it by heating it up, and as a result of all of that, they started to realize that there was some off-gassing taking place that was toxic and corrosive, and those gases were being measured. But in every fire that we go to, we usually deal with toxic and corrosive gases, and any firefighters that are on here know exactly what I'm talking about. So we weren't too concerned about that, but here's the next one that we're concerned about: flammable cocktail. Along with the toxic and toxic corrosive gases, there were other gases, hydrocarbon gases, that were inside that flammable cocktail. And the moment that we recognized that within New York City, in our little group, we immediately thought about the potential of an explosion. So if this thing were to go on fire, well, we're consuming all those flammable gases. It's when it's not on fire that we need to be concerned. And if you're familiar with an incident that took place in Arizona, there was an explosion that took place, and the flammable gases that were produced inside the container itself were wound up finding an ignition source, and there was an explosion, and some firefighters got hurt. Thank God they're okay today. But that's our biggest concern with this is if this thing does go south, we need to be concerned about the explosion hazard. And that's the reason for the deflagration venting in the enclosure that Jennifer had alluded to earlier in the conversation. So you can start to see the overlap now, why things are put in there for the code, because it's there to protect the firefighters if they were at a scene. Also, there's deep-seated fires. So if a firefighter were to pull up to the scene and they were taking their thermal imaging camera that they use quite frequently to look for heat sources, some of these heat sources may be too deep inside the cabinet or in the module itself for them to see. So they may not be able to see it. Probably there's a good chance they won't see it, and that's not a bad thing. We really don't want the firefighters going in there right away. As a matter of fact, we'd like to keep them out as much as possible, and we're going to explain later on how we're going to do that. So when there is a deep-seated fire and the firefighters do not see it or cannot pick it up on their thermal imaging camera, there could be a delayed ignition. So firefighters show up to the scene, nothing is showing. It's easy when there's a fire showing, we know what we have to do. When there is no fire showing, that's when it becomes a problem for us. And that delayed ignition is a concern. So the firefighters show up, they see nothing, and then sure enough, 3 hours later, you have this thing up in flames as a result of not being able to see anything on their thermal imaging camera. What we also learned in this testing data was reignition. And this has happened quite frequently, and it goes back to, again, the codes and what the code officials are asking for. Reignition is a very real concern with lithium ion. So when these things go on fire and the firefighters will put them out, or the suppression systems may put them out or manage them and extinguish these things, there's a good chance that these things will go back on fire within a 24-hour period. And there was one test that was done where the battery was put out with a hose line, and this was in the testing lab, just so you know. It was put out with a hose line, and it went on 9 times in that 24-hour period. So that's a very real concern for the firefighters, which brings us back to the fire remediation team and how Jennifer said the firefighters do not want to sit on this thing all night long waiting for this thing to go on fire again if it does go on fire. So what they're going to do is they're going to have that handoff procedure, and that's something that you may require in your jurisdiction. And then last but not least, we still have that stored and stranded energy even after the burn. After the burn, that energy does not dissipate. It could, but there's a chance that it doesn't. So we always like to tell the firefighters, always consider that thing charged and it still has energy inside of it. Next slide, please. So I'm just going to give you a little bit about what happens if you show up to the scene, no fire showing. You can see this container right here. The fire department may get a call to this type of enclosure, and maybe there was a smoke alarm that went off. So they show up to the scene and they say, well, I don't see anything showing. I don't see any heat source pointing my thermal imaging from a distance. So what do I do in that situation, right? Was there an electrolyte vapor released inside there, right? Is this a flammable atmosphere inside here if this smoke is not pushing outside? Because this is what we saw in Arizona, where they couldn't see anything. And they actually took their thermal imaging camera, they walked around, it was a structure, not a container, but they walked around the structure. It almost looked like a container. They walked around that, and they actually sized that thing up for 2.5 hours before they actually made entry. And we learned a lot from that. We really don't want you making entry into these things. There's no life safety involved. People are not supposed to be living in there. So there's no reason for us to send our firefighters into an electrically charged, stored energy system like this. For outdoor installations, there's really no reason for us to get in there. The batteries, if there is a heat source going on in there and we just haven't seen it yet, those batteries, after certain degrees, can no longer be used. So they're going to have to remove them anyway. They're not going to be put back in service. We also need to be concerned about environmental and the floods or earthquakes if there is something that may have caused that to go away and maybe an internal short circuit had taken place. Another thing that Jennifer said that during lithium ion, this type of enclosure here, you don't need a ventilation. But I'm going to ask you, let's say there is a flammable cocktail that's in there where the cell heated up and all this gas came in and now it's stored inside there. How do you get it out when there's no ventilation? And this is what they saw in Arizona. They weren't able to get out any gases, but when they opened up a door that was part of the structure itself, the gases started coming out. Now, was it too rich to burn at that particular time? We don't know. There's still some forensics on it, so I don't want to talk too much about it, but I can tell you what I know at this particular point. So what New York City decided to do is to try to have some sort of ventilation for the firefighters to release those gases so they wouldn't put their forces right next to the actual enclosure itself. So that fan would actually pull those gases out. Would it stop an explosion? It may not stop an explosion, but the firefighters could still be a distance away when they turn that exhaust fan on to pull that stuff out. So that would be a remote turn-on switch for them to use, and they would pull the gases out of there. And also, the fire department would like to have a subject matter expert, so someone that they can call and say, hey, listen, I'm at this location. What type of chemistry in there? What do you have for a suppression system? Are you showing anything on that BMS? Now we get into this thing called the BMS that Jennifer also mentioned. That was a component of it, the eyes and ears, she called it, the brains of it. Does that show any type of data that we should be concerned about? Is it showing any type of rise in temperature? And if so, are we at a temperature where we possibly could have a vent of those gases into that? Next slide, please. All right. So this again becomes easy for firefighters. When they see fire or smoke, there's really no guessing anymore, right? We know we have something. So what do we do in that situation? What we want to do is we want to control the spread of the fire. We're not going to put these, if you see the enclosure on the right-hand side of your screen, we're not going to put that fire out. That fire is not going to go out, right? How are we going to get the hose line in there? Do you want to commit your forces in there? I wouldn't. As a matter of fact, I'm telling you, for any firefighters or chiefs that are on there, don't do that. It's not a good idea. You're not saving anything. It's kind of like a car fire. When's the last time you saved a car in a car fire? You just don't do it. That car is demolished. The same with this. And the installers know that. And the installers are starting to realize, like, look, you're not saving our property. These things got to be removed anyway. So what we would try to do is try to make sure that that heat that's being transferred out of the enclosure doesn't go to the adjacent enclosure and get that one to go on fire. So basically, you're putting up a protection line. That's what you're really doing. So when there's smoke and no fire for the incident commanders, you got to think of an explosion concern right there. When you actually see the smoke, and what we have noticed in a lot of the testing that has taken place, when we heat these batteries up and they're not on fire yet, they will produce a white smoke. And that white smoke is that flammable cocktail that I mentioned before. And that flammable cocktail is made up of a lot of different hydrocarbons. And the biggest part of the mixture is hydrogen. Hydrogen, as we said before, is extremely explosive and causes a lot of the flame speed on it, and the pressure that's pushed out there would cause a violent explosion. We also want the firefighters to keep away from these containers. There's really no reason for us to go there. We want to rely on that subject matter expert to be the point person to give some sort of direction. As always, whenever you have a fire or a condition of an emergency, the proper PPE is what we want you to wear, which is your structural firefighting gear. Reduce any smoke exposure. So if this is pushing smoke out of it, we don't want you to be in that smoke, because I just told you before that it's toxic and it's corrosive. So stay out of the smoke. Try to find a water source. And I realize that there are some places that don't have water readily available. Not a big problem in New York, but if you're upstate and you don't have a water source, you may want to bring one of the tankers to this location in case you need it, to make sure that you can keep the fire from jumping to the container next to it. Making sure that there's no life hazards. As I said before, they're not supposed to have any people in here. There's no reason to have people in here. They have the security fence. Does it mean that no one's in there? Well, guess what? I still wouldn't commit my forces in there, because if you were to put the firefighters in there with this smoky condition, a potential explosion event taking place in there, and also all that stored and stranded energy in there, even though you shut the power down, open bus bars, you're really not doing justice to the firefighter in that situation. If these doors aren't open, you better assume that there's no one in there, right? Whenever we go in and put our lives on the line, it's always for a known life hazard, not for a suspected life hazard. And I have that in there. Do not open or enter that container. Do not stand in front of the doorway. So if there was an explosion, you can see on top of this container that you have in this picture here, the pressure is supposed to go up into the top areas in that deflagration venting area. So that's just supposed to absorb all that pressure. But the doorway still could be a weak point, and we want to make sure that those doorways are not actually coming off and hitting one of our firefighters. So making sure that the firefighters are not standing in line of sight of those doorways where they can actually blow off and hit one of the firefighters. And then again, last but not least, use that subject matter expert. Call them for help. Make sure that number is on the signage that is required, that you can call back and have someone go over that with them. Next slide. Continuing to go on with the fire, if there is a fire, you can use a hand line, use a fog nozzle at 10 degrees. But the reason that we did this and we put that in there is because UL did some testing on it, right? We're not taught to put water on electrical components. And this is electrical component. Not only is it electrical, it's electrochemical. And usually we don't use water in that situation. But we're telling you, you can use water in this situation. If you were putting water directly onto an energy storage cabinet, then just be concerned about potential of electrical leakage back to the person that's on the nozzle itself. And that's why we tell you to use a 10-degree fog nozzle to actually limit the amount of energy coming back. Look, we also tell you to stay 10 feet back if you're concerned about that. I want you to be back even further than 10 feet. Is really use the reach of the hose line itself and have your forces stay back. Stopping that spread of fire is going to be the key to make sure that it doesn't jump from one container to the next. Do not use foam or additives. If you go to the DOT transportation book and you look up lithium-ion batteries, it will tell you to use foam. And then there's other people out there that's saying, hey, if you add this into your water, it's going to help you with the lithium-ion. I have not seen any data showing that additives to water help to put the lithium-ion fires out faster. So just be leery of that. And if people do have something that they can add in there that's actually going to put the lithium-ion battery out faster than plain old water, just have them show you the data. I'm open to suggestions, but no one has showed me data to say that this product works better than water. The reason that we don't want to use foam is because foam does not have the cooling capacity as water. Water has better cooling capacity than foam. Foam is really used just to suppress vapors, and that's the major reason why we use foam. And we use them at hydrocarbon spills, that we don't have those gases starting to evaporate. We suppress those vapors coming off the actual liquid itself. Keeping your distance. If there is some sort of water collection, we want to make sure that the firefighters do not stand in that water pool. Potential of, again, electrical leakage coming back to them. Watch the runoff. If this container that we see again is on the rooftop and you have some way of introducing water, or there's an automatic sprinkler, we got to make sure that the water doesn't collect in here, because now you're just putting extra weight that's on the rooftop itself. So we got to make sure there's some sort of runoff there. So for those people that are using or that are looking at the plans for this stuff, ask them that question. How does the water get out of there if we're on a rooftop? We don't want that water collecting inside the cabinet itself. Also, the environmental issues that could surround the water. I don't have much information on that, about the runoff. In some situations, if this thing was on fire, I may just allow this thing to burn, right? What am I saving? I may just allow it to burn, and that's got to be something that the incident commander will make that choice at the scene itself. And then last but not least, this last bullet here, we talk about LithX. There's this stuff out there called LithX that is used for lithium metal fires. This is not a lithium metal fire. This is a lithium salt. And anyone that knows a little bit about hazmat, which was my thing, whenever you have a IUM metal, lithium, magnesium, titanium, they always told us never use water on a IUM fire. Well, this one here, this is not lithium metal, this is a lithium salt. So we can use water safely with no reaction on that. Next slide. Ventilation and exhaust. This is not required for lithium ion. It is required for lead acid batteries, and we talked about that. During a normal operation, lead acid batteries will actually off-gas some hydrogen. If that hydrogen starts to build up inside and it gets to 25% of its lower flammable limits, this exhaust fan should kick on pulling that stuff out. But as I mentioned, what I also mentioned, during an abnormal situation in lithium ion, if we get that flammable cocktail and now it's stuck inside the enclosure itself, how are you getting that stuff out of there? And this is what some people are adding into their enclosures. If that stuff comes out automatically, where it doesn't have to, where it doesn't get trapped inside the enclosure, then they should be good to go. Does that mean there's no explosion? Well, I can't say that. Some of that stuff can still get caught in some of the pockets of the enclosure. It's not practical to put one of these fans in there. Eventually it will come out. But to tell you that there couldn't be a small little explosion inside the cabinet itself, like the cabinet that Jennifer showed you before, something got caught into the interior of that stuff. Would there be a pocket in there that could cause a little bit of an explosion? Yes. How bad is it going to be? I don't know. But if people are going to put these exhaust fins inside of those enclosures, you want to have remote access. We don't want the firefighters walking right up to the enclosure itself to activate that thing. because once it starts pulling, it may bring it down into its flammable range and cause an explosion to take place. What is my ignition source? An internal short circuit, which could be anywhere within that system itself. In some situations, there is suppression agents called clean agents that are used in these lithium-ion installations. So the clean agent will come in there, and basically what it does is kind of removes oxygen or reacts with the gases in there to make sure it doesn't go on fire. But when you remove that out of from the exhaust location, now you're removing the clean agent. So there are things that are automatically that come with clean agents already installed inside of them. In New York City, we have seen that. We've seen dual agents. We've seen a clean agent, but New York City said you still want some sort of water going on the inside. And what they did is they put that dry pipe where the engine would just come in and they would just dump their water right through the dry pipe and into the actual enclosure where the firefighter would never have to get involved and they wouldn't make entry into it. There was always concerned about that the firefighters would actually put water in there unnecessarily. Well, those sprinkler systems are fused heads. They will burn out at about 165 or 175 degrees Fahrenheit, and then the water can start to flow. Until then, those fused heads will not allow the water to flow in there. So if it got to 165 or 175, again, the batteries now cannot withstand that temperature. They probably are going to be removed from service anyway. So we're not really ruining anything. Those batteries probably are coming out of service anyway. So when you remove any of that stuff, now you introduce it, your makeup air is going to have some oxygen in it, and it makes it just right for a possible explosion taking place. Okay, we can go, you could see the last bullet with the star on it where it says these things may not be part of the installation, and it's also not required. This is something that the AHJ may actually require as part of the installation. But again, it's not required in your code, but it's something that sometimes people say, hey, would you do us a favor and put that in there. Next. Clean agents, as we said before, most firefighters, you know, when I was talking about clean agents and firefighters within the FDNY, most of them looked at me cross-eyed, like, what is a clean agent? So I had to explain that. So the firefighters that are not out there, when you have components, we see this quite frequently with electrical components, where we don't want to use water. If you've ever been to a fire in an electrical room, they basically are saying, do not use water in this room, because they know they usually don't mix, right? That's what we don't want to do. But they will have some sort of clean agent. So that clean agent generally, as a rule of thumb, will take out some of the oxygen. So you better be on your SCBA if there is a clean agent, and you really shouldn't be going in there. But you don't want to open up a doorway to a room or an enclosure that has released its clean agent, because it's not a good place for us to be. And also there is a hold time that needs to take place. These things just don't happen immediately. There is an amount of hold time that needs to take place for it to do its thing, to put the fire out. These things we have, in New York City, we're concerned about these things being used to put fires out in these energy storage systems. Because if you have an internal short circuit, once you remove that clean agent, that internal short circuit will continue to go, and it may cause the fire to go. So this clean agent, when people put these things in there for lithium ion or other types of chemistries, they should prove that the clean agent will work to put that fire out. If they don't prove it with the data, then you may require them to have another system in there that deals with water. So the sprinkler system itself could be automatic, or you could have a dry pipe system that we used in New York City. And the reason that we went with dry pipe is because we were concerned about freezing weather. And then if it was frozen and that water were to seep in there, well, now we just caused the problem that we didn't want to cause before. So we wanted dry pipe specifically for outdoor installation. For indoor installations, you probably won't have that. That's going to be an automatic one. Plus, if it's also on a rooftop, you may have automatic. So that's something that you're going to have to take a look at and make your decision on that. As I said before, they're going to be closed heads inside there. And in some remote locations, they won't have any extinguishing agent. And that's up to the people that are permitting it, the code official, to say, all right, I'm going to accept this with no extinguishing agents at all. That's inside the code. So firefighters may just want to stand back and let these things burn. Because if it's inside the enclosure, we don't want to commit forces in there. We just want to make sure it doesn't spread to the next one. Next slide. The shutdown. We said before, the shutdown, when firefighters are shutting these things down, if there is some installations that have more than just one enclosure, maybe it has 90 enclosures, is that shutdown system actually shutting down all 90 enclosures, or is it just shutting down the one enclosure? And this is where the AHJ has to take a look at that electrical connection to see how they're doing it. And if that emergency is for the whole system, well, in the event of an emergency with no fire showing, maybe we just had a cell go bad, but the system continued to operate perfectly, do we want the responders actually shutting that thing down unnecessarily? So this is where the education comes into the firefighters. We don't want them shutting that thing down unnecessarily. If they shut it down and then that whole thing just stops, someone has to come back out there and do a full check on all 90 of these things, making sure they work properly before it goes back into service. So these emergency shutdowns, although they are good, we have to use them cautiously. If there was an incident that takes place inside one enclosure out of those 90 that I just mentioned before, the BMS should have picked it up, and the BMS should automatically shut that down. But I can tell you this, when firefighters see an emergency shutdown button and it's electric involved, they're shutting it down, because they usually give a communication on the ground to everyone, power's shut off, and that's what they do. That's very typical. I don't blame them for doing. That's what they've been taught since their fire academy days. So something that you need to be concerned about is, if they did shut it down, that BMS that they're trying to collect data from, they're trying to figure out where there is a trending rising temperature, let's make sure that that emergency shutdown doesn't shut down that data, because that's something that they may utilize later on to figure out whether we have a trending temperature where we have a thermal reaction taking place and it's continuing to go, or if it is actually something that did take place and now this thing is running normally. So again, interpretation of the data from that battery management system, the eyes and ears, is going to be key for some incident commanders moving forward. Also, does it shut down the HVAC system? If it's in the middle of the summer and the sun is beating down on these things, could we have a problem if the HVAC goes off? These things are what they call the Goldilocks batteries, the lithium ion. They need to be just right, just the right temperature for optimum efficiency. So when we shut down the HVAC, are we actually causing a problem? Something to consider again. And then below, before we talked already about the BMS and whether the BMS should automatically shut those things down. It's part of the safety package. There's many layers of safety. There's got to be a lot to take place for these things to go south. Can it happen? Sure. The chances of it happen are slim. Can't say it could never happen. That would be irresponsible. But anyway, the BMS should actually shut these things down when it detects some sort of problem with the batteries themselves. Next slide. The subject matter expert. So if you're requiring to have some sort of subject matter expert, it should be on the signage. There should be a telephone number. Heads up. You should call that number every so often to make sure that someone's actually picking that phone up. Because we don't want to be there at 3 o'clock in the morning where the fire department's calling that number and no one's actually responding. So if that's part of your inspections, maybe you want to give that number a call just to say, hey, this is the inspection unit. Just making sure that someone actually responds to this telephone number. The subject matter may respond, or they actually may just give information over the phone. And that would be dependent on the incident commander, whether they needed that person there at that particular time or not. They also may give you an idea on whether you want to shut these things down and what is the procedures to shut them down. Is it just shut the emergency shut-off down, or is there other procedures that can take place? A lot of these things will be in unstaffed locations, so there'll be no one there for the firefighter to help them. When they're on utility property and managed property, I feel actually better about that, because now you have at least the facility people who know a little bit about this that can hold your hand when you get in there as a firefighter. They can also advise you on ventilation. If this thing has a ventilator in there, something that's going to exhaust that smoke out, can we turn it on, or what do you suggest? And this is where you have to go back and forth and ask that subject matter expert their advice on what to do in that situation. They also should be the person that should be calling that decommissioning company. So let's say there is a fire where we have 4 or 5 containers that went on fire. There still could be that stranded energy there. It didn't dissipate as a result of the fire. Now you have an unsafe scene. Who's going to secure that location? Get the subject matter expert to get the decommissioning process starting to move on that situation. But the main reason that they're there is really to advise the incident commander. Next. All right. For indoor systems, indoor systems are going to be a little bit different, right? I told you before where we may want to let these things burn, right? Well, when you're indoors, insurance companies don't want to hear that you're letting these things burn. So we may have to actually go inside and do some work on the inside. But if we're going in, we want to make sure that we're safe with the water. We want to make sure that we keep that distance that I mentioned before if we have to go into a room, right? We also want to make sure that the sprinkler systems that the AHJs we're using were there to actually manage the fire. So if you don't have the right proper density of water going in there to manage the fire, you're not doing a favor to the firefighters. Now they have to go in there and put more water on it with their hose lines. And if they are operating on it, we don't want them to go deep inside that room because of the fact that that stranded energy will still be there. Next slide. Okay. Smoke and fire inside the building, right? You're probably going to evacuate the building. If it's a dedicated building, move all the people out. If it's in a high rise, then guess what? The floors above are going to go out, and maybe even the fire safety director will actually dump the whole building. When you dump the whole building, that becomes a major problem for us. But that will be up to the fire safety director inside the building or some fire brigade that's inside the building itself. We do not really want you to enter the room, especially when that LEL sensor is sounding. So maybe they have some sort of detection system that is actually measuring the hydrocarbons in there. If that thing is sounding, that means that you're getting close to the explosive limit. And you may be at that explosive limit. So are we going to exhaust this stuff? Where do we go? We have to be ready for explosions in this situation when that LEL sensor is sounding and making a noise. When there is smoke and no fire, that is our biggest concern. I'd rather see this stuff on fire than actually see the smoke because of the explosion hazard that we need to be dealing with. We do not want you to enter that room during the ventilation of the room. So if this thing is kicked on, what happens if we're above the upper explosive limit? We could be bringing it down into the just right area where we could have explosions. So we want you to really kind of stay out of the room when there is no fire showing. If there is fire showing, well, guess what? It's consuming any of that off-gassing that we're concerned about. Make sure that sprinkler system is working. That's a big thing, right? That's going to help you to suppress some of those vapors. Sometimes that sprinkler system is not enough to actually put that fire out because when these things do go on fire, they're like a jet fire, right? It's like a propane tank that's on fire where that jet stream is coming out. Very hard to put those things out. As a matter of fact, we usually just shut off the valve itself to put those things out because it's very hard to push back on those things. Check any exhaust and exit ports to make sure that they're not having any fire that's coming out of them, call that subject matter expert, call them in there. Maybe they're at the location at that particular time. And then also, we want you to stay out of the doorways again, right? Making sure that you're not inside the doorways themselves. Next slide. So this is a picture of a UPS system. But if I asked you what chemistry this is, some of you may know, and some of you may have no idea. But this was inside a high-rise building in Manhattan. And when I went in there, I knew the fire safety director. He was retired from the fire service. I asked him if I could see one of his UPS systems. And when I went to the building that day, I said, great, would you mind if I take a look at the UPS system? He said, well, which floor do you want to go to? So they had 7 of these things, full rooms full of batteries for UPS, uninterrupted power supply for those people who don't know. So those things would only be used in the event that there was a grid failure. They would hold the load for the critical things inside the building itself. So for dedicated use building, right, ensure that there's no life hazards. That's our biggest thing, right? Making sure that those people are out and we have accountability of those things. If accountability is not there, we only go in for a known viable life. And then that word viable is big, right? If we get there within 20 and 30 minutes and there's a tremendous amount of smoke, what's the chances that these people are going to be viable? We're going to make our best effort, but remember, we're going in for viable life, not people that are already dead. That's a recovery. The smoke, if there is smoke and fire, we don't want you to enter the room at that particular time. Get information from the battery company. Call that subject matter expert. But again, relying on the extinguishing system to do what it needs to do. Right? This is where that large-scale testing comes in. If the large-scale testing says you need to have a 0.3 or 0.5 gallons per minute per square foot, then that's what you need to have for the installation. So don't be afraid to ask. So when you go over a certain threshold, that large-scale testing has to take place. And we didn't get deep into that 9540A, but that's a pretty good test to make sure that when these things go in, that they can be controlled if they go on fire. Next slide, please. All right, rooftop installations. If they were on the rooftop, we want to shut down that system. This now, when they're on a rooftop, generally they're dedicated to one particular building. Usually you don't put a energy storage system that is going for the rooftop, on top of a rooftop that's the building 10 miles away. That thing is usually for just the building itself. So shutting that thing down is really not going to affect anything else except the building. But that's a normal operations. We normally shut down the systems or the electrical inside a building when we go into a building itself when we have a fire going on. If there is a fan, we want to exhaust any of that stuff that's inside the cabinets itself. Prepare for an explosion if there is. But when it's on fire, we told you before, that's good because it's consuming any of those gases that may have actually been liberated inside a heating event. Making sure that the firefighters have good access to the roof. We like to have a bulkhead on the roof. If they are going to go to the roof, making sure that they don't put that ladder right where those energy storage systems are. And this is why pre-planning and the firefighters doing a walkthrough when these things are installed are important to make sure that the roof access is not hindered if they were to throw the ladder up to the actual roof itself. Water access to the roof is a must. If the firefighters get up there, they want to have some sort of water access or their own protection line. So a standpipe going up to the top of the roof inside the bulkhead where they can stretch a line off that, and the firefighters can feed that standpipe from outside, and this way the firefighters can have their own protection line for themselves to making sure that if we have one of these cabinets on fire, that it doesn't propagate to the cabinet that's adjacent to it. We also can augment the water supply for any type of fire that's there. So if this has a sprinkler system, there may be the fire department is showing up with their engine to augment that sprinkler system in there. But again, making sure that we look at the runoff from these enclosures, because we have to worry about the weight itself. Next. Residential. If you are at a residential fire and it has an energy storage system, that communication should be put on the fire ground immediately, right? We also would start to extinguish this thing immediately. We can throw a hose line right onto the actual cabinet itself that may be adjacent to the wall. Some of them are going to be attached right to the wall. We want to get this thing out as quick as possible. As I said before, just use what I said as far as staying a distance away, up to 10 feet, making sure you have that 10 degrees on a fog nozzle, and trying to knock down those flames so it doesn't propagate into the structure itself. The locations that they can be found is inside the garage, on the outside of the building itself, and there is no signage for firefighters to know whether this thing is out there, but they should start to be aware that these things will start popping up on private dwellings. But they will be outdoors in private dwellings too, making sure that they have clear access to them if they do need to stretch a line to the rear of the house to get water on the energy storage system that's on the back of the wall. But they also can be in indoors, right? And they can be indoors in utility closets. So if there was a structure fire and it had nothing to do with the energy storage system itself, the heat from the contents burning inside the building may actually cause a problem with those energy storage systems that are inside the building or even on the exterior building or in the garage. So any type of heat or excessive heat that these energy storage systems are exposed to could be a problem. For firefighters, at this particular point, you could probably use your thermal imaging camera and see any rise in temperature because you can get pretty close to these things. Any type of gases that would be liberated in there that are not on fire should actually exit the enclosure, and the chances of explosion are not great. I can't say they can never happen. Again, that would be irresponsible to say something like that. There could be several of them. It could be up to 4 on the outside. 4 of these particular cabinets could be on the outside of them. So it may be more than just one of them in there. They do not have any fire suppression in a private dwelling. They will not have them in the residential ones. And they may have a smoke alarm or an IR detector, infrared. So in garages, for instance, smoke alarms may not be used. They may use a infrared detector to look for flames. So all of that stuff should be included if you're putting them inside the building itself. If they're outdoors, guess what? Smoke detectors are not going to work. But inside a garage, you may use an IR camera, or inside utility closet on the interior, you're going to have some sort of smoke alarm. Next slide. Post-fire events. So when I was in our meetings in Brooklyn, I started to realize, knowing about the reignition, I went into my chief's office and I said, Chief, I am concerned about the fires, obviously, but what do we do after the fire? He goes, what do you mean? I said, how do we get them out of the building with the reignition problem? And he said, wow, that's a concern. This is where the decommissioning plan comes in. Ask them how they're going to do it, how they plan on getting these things out of the building if they're in the building, or if they're on the rooftop. What's a safe way to get them off the top of the roof? So what do I need to be concerned about? Who's going to safeguard the scene? Is it going to be that subject matter expert, or is it going to be the fire department? It could be the fire department if you guys don't ask for it. It could be someone else if you do ask for them to actually have someone show up there. When can we investigate the origin of the fire? And the insurance companies are always looking at, well, hey, was it something else that caused the fire? Was the battery that caused the fire? And we're starting to see the insurance companies now start to grab their territory and say, we don't want to move these things out so quickly until we do our little investigation. And that's going to be something that needs to be ironed out. If you are a fire commander, what is your role at the post-fire event? You're going to have to sign off on a proper decommissioning that they actually give to you and say, this is how we're going to plan to do it. Here's our emergency response plan to remove these things. Here's how we're going to actually transport these things out of the location. Now you got them on the back of a truck. Could they reignite on the back of a truck? I'll let you answer that. When can you reoccupy the building? Whenever there is a fire and an event, one of the things that people are always asking for is, when can I get back into my building, right? When do we have continuity of operations in the building itself? How will these things be transported? How do you remove the systems from the building? It's safely, right? And we kind of went into that. So post-fire is still something that we need to be concerned about. Even when these things are still smoldering, when they smolder, they could still off-gas that flammable gas again. So making sure that you have good ventilation even after the fire is so important because of the reignition, and now you have all that accumulation of those hydrocarbons that could be trapped inside that enclosure again. Next slide. Some of the things with the post-fire considerations, I kind of went over these already. We talked about the reignition. We also talked about compromised safety features, right? So now these, if there was an event that took place, but there really was no fire, but there was a high temperature reading, are the safety features that were in there, are they still good, or were they ruined as a result of that excess heat? I don't know. I don't have that answer. Is there still stranded energy? Always assume that the state of charge, SOC, state of charge, is at 100%. And how do we remove that state of charge safely? Do you want to remove it safely? In 855, they say this is one of the things that we should be thinking about. But guess what? We may not be able to move it safely. You may not be able to remove that actual energy safely. So this is where the incident commander's got to make that decision. Like, hey, you know what? You may not want to remove it because you can't do it safe enough. There may be other ones that you can remove safely, but the ones that are damaged, you may not be able to remove that energy safely. What is needed for the safety itself? What does the incident commander need? Do they need accountability? Who's going to be doing the decommissioning? How long is this decommissioning going to take place? All of that stuff needs to be thought out during a post-fire event. What type of monitoring devices? What is the proper PPE? The people that are removing them, right? It's not going to be firefighters. Firefighters weren't trained to remove these things. It's going to be other people that are coming in there to remove these things that are compromised and remove them safely. What type of PPE should they be wearing? Technically, the incident commander is still in charge of that scene, right? So they're in charge of everyone's safety unless they designate someone else to take over. Is the BMS still operational? Is it giving us any information? Is it on? Is it off? Is it giving that information? And can we get information from that BMS? And again, going back to the transportation of this stuff. What is the proper transportation? Is what routes going to be taken? And will the Department of Transportation start to look into this? So US DOT is aware that this is a gap for them. And don't know what they're doing about it. But they are aware that this is a gap. They have a lot on their plate. But I sit on the FAA, DOT FAA Transportation Board. When I was down in Washington, D.C., I made it very clear that this is a problem. So hopefully they address it soon. Next. Some of the chief's responsibilities, reviewing those decommissioning procedures, what is acceptance criteria for you, the transportation plan, making sure that you sign off on that, right? And there's really very little guidance on it. So we have to really think about that. And 855, the committee in 855 is also thinking about, like, maybe we should give some ideas to these chiefs moving forward. Again, what's your acceptance criteria is there for a second time inquire with the recovery of the location. Where are you bringing these things to? Oh, we're bringing them down the block, right next to a private dwelling. There's an empty lot there. That's where we're going to bring them. Well, now we have these things possibly going on fire again, right? and with the proper protections in your jurisdiction. Hey, if you can see this picture here on the right-hand side of the screen, I was out in San Diego at a conference one day, and I get a call from my guys in our hazmat unit, and they send this picture to me, and they said, "Is this a battery?" I said, "Yeah, it looks like a module." Well, sure enough, someone had actually taken this battery, and they threw it out in the regular garbage on the street corner. The sanitation truck came, threw it in the back of the sanitation hopper there. The blade comes down, crushes it, and this thing wound up exploding with energy still in there. Exploding meaning that there was some pressure put out there. I don't want you to think there was a massive explosion, but there was a little bit of an explosion, and there was still energy in there. So they had this thing on the corner of 42nd Street and 3rd Avenue in the middle of Manhattan, wondering what to do with it. Now the fire department owns it. How did they get rid of that? Who takes control of that? There was no owner around. Well, for any cops that are on here, the cops wound up taking it for their own forensics. And when they told me that, I said, good, now we don't own it. But seriously, all kidding aside, who's going to take responsibility of this energy storage, this thing here? Even though it's not part of the energy storage system, we don't want to take any of this stuff back to our firehouses. Next slide. Post-decommissioning, fire commander, that's their role. They should be giving you a narrative of their removal process. List of contingency. What happens if it does go on fire? What are you going to do? Do you have a protection line still there set up? Are you going to be able to put it out with fire? Are you going to let it burn? Are you going to call the fire department back? What's your communications method to get them back? The fire mitigation personnel that you may require. Are they going to be the regular street sweeper that really have no idea of these things? What's their professional qualifications? What do they plan to do when they get up to the actual incident? Are they going to just basically watch it? Are they going to do a little bit more than that? How are they going to contact the fire department? Are they going to follow the decommissioning plan? Are they part of a safety plan? All of these things need to be discussed when there is a decommissioning. As you're starting to notice, decommissioning is going to be a big thing here. All right, I know we're coming up on 7:30. I don't want to hold you that much longer. Let's go on to the next slide. I think we're coming near the end. If there is a post-fire event, or when they're removing these module by module, we want to have some sort of bucket there. Maybe that's going to be in there. And if they actually start to heat up or go into a thermal runaway event, they can drop it in the bucket. It's just something simple like that just to stop the propagation. If you submerge these batteries, that water is going to actually absorb the heat. And then you see where I said a salt bath. There are some car manufacturers, when they do have an event that takes place when they're changing lithium-ion batteries at their car locations, they use a bucket of water like this, and they put a salt bath in there. And what the salt will help to do, will help to remove that energy, right? It will stay in there. They're not going to take it out, but it's going to stay there for a while until that energy is all removed, and they get scrubbed out as a result of the salt causing that energy to be released. If they are going in, what's the proper packaging for all of these transportation vehicles? DOT regulations really are silent on this. Is it going to be an open back type of transport, or are you going to have it inside a closed back? I personally think it should be open back. Should it go through tunnels or not go through tunnels? I don't think it should be going through tunnels. All of these things need to be discussed when they're removing these. Next. Okay. So just to let you know, we're trying to actually call these things energetic hazardous materials. So they're really not classified in some situations as hazardous materials. So we're saying, well, we want the DOT to classify these as energetic hazardous materials when they're shipping them. So DOT calls it a hazardous material, but they call it miscellaneous. This is a problem. I think it should almost have its own division inside of it. OSHA, part of their work safety, they do have an SDS sheet. Well, some people are saying OSHA doesn't say this is a hazardous material. So there's a discussion about that as far as the worker safety and the SDS sheet. Some people say we don't have an SDS sheet because it's not a hazardous material. And then the environment, the EPA. What do we do with that runoff water? I had them check out some of the runoff water at a test, and there was some corrosives. But I also had our guys at one of their structure fires take a piece of pH paper and throw it into the runoff at a structure fire, and sure enough, it came up corrosive. So these things, as far as I'm concerned, they're similar to a structure fire as far as corrosivity is concerned, but I'm sure there's a lot more deeper studies that need to be done with that. But that's what just my unscientific way of saying, hey, there's going to be corrosive fire, there's going to be structure fires that have corrosive runoff. Next. All right, just to kind of review, for the operational people, all right, this pyramid here, the explosions are our number one concern. We do not have any personal protective equipment to actually protect us against any type of explosion during an operation phase or any phase at all. But also we need to be concerned about the high heat. These things have a very high heat release rate. So if they are using water or you're using some sort of hose line on it, you're going to have to use a lot of water to absorb the amount of heat. And keep that in mind when we don't want it to propagate to the cabinet next to it. We'll have the stranded energy that's going to be involved not only in the operational stage, but also in the post-operation stage. The reignition is very, very real during the post-operations. And also, we do not want firefighters doing any type of overhauling. There's no reason for us to look for pockets of fire in this thing. Leave it be. Decommissioning is also going to be part of that post-fire event. Next. Just a couple of pictures of some installations here. I usually ask the class, take a look. This is an energy storage system in a garage in downtown Manhattan. What chemistry is that? And most people have no idea. That's actually a lead acid based chemistry. You wouldn't be able to tell unless we had signage that said this chemistry is lead acid based. So making sure that the proper signage is there is important. If you take a look, I have an arrow pointing up to the sprinkler system. How effective is that sprinkler system going to be able to get to the fire that's inside the cabinets itself? Or if you see that thing that says water there with a question mark, even if they had a hose line there, we're not getting to the seat of the fire in this one. This is going to be a tough one. But that's why they got all these resilient safety features inside to make sure that these things do not go on fire. Can I say they never go on fire? No, can't say that. Next. All right, we kind of already went into this Arizona case study, and I'm getting near the end of my time, but just know that 8 firefighters were hurt. 2 were hurt pretty serious, right? There was response information that they had, but when they showed up to the scene, they did not have any fire showing, and I said before, they went 2 hours size up on those. For 2 hours, they did stretch a line, and when they opened the door, there was some white smoke that came out. If you can see at the far end, you can see the little doorway open there. That stuff, this white smoke started to hug the ground, and they said about 3 to 5 minutes later, there was an explosion. All the pressure pushed outside that door, and it pushed the captain back about 75 feet. That captain, thank God, is fully recovered. I actually spoke with him. He had some really good insight. Still, again, this is under litigation, so I don't want to speak too much about it, but I can tell you that those firefighters were blown a good distance away. And there was also debris. If you can see those ventilation, the HVAC systems that are against the wall there, those cover plates, they went flying. They become projectiles. That's a problem for us. And the post-fire event for this thing, it took them months to actually decommission this, which was a problem for us. They learned a lot, and I'm not saying it's going to take months for other decommissioning, but they learned a lot about how to decommission because they weren't sure how to do this. It was the first one that was decommissioned in that way after an event. Next slide. Well, that's it. I went about 7 minutes over, and I apologize for that, but I had a lot to tell you. If you need to get in touch with me, you can go through NYSERDA, I guess through Jennifer or Ian. And Ian, I'm going to leave it back up to you. Looks like I got a lot of questions here.
Yeah, thank you guys so much for your contributions and your presentations tonight. We do have a list of questions that we'll just want to run through, and to all the attendees, thank you guys for sticking with us. I know we're a few minutes over, but we'll go ahead and try and run through some of these questions. Got some really good questions, and we made note of them all throughout, so we'll go ahead and just get started at the beginning. We had a question starting at slide 24 regarding the time until the mitigation team is expected to arrive. I don't know if we want to go back to slide 24 there, but yeah, the question was how long until the mitigation team arrives?
I can answer that. That was left up to the AHJ. So that is a fluid conversation between you and the people that are doing the installation. What you feel is reasonable may not be reasonable to other people. So you should nail down a time, but there is nothing in the code that actually says they need to be there within a specific amount of time. That's why they have the phone number that you can call up for an emergency operations to guide them through. But for someone to actually take over the scene, that's entirely up to you, whoever is the code official.
Okay, thanks. Thank you, Paul. I know, Paul, you addressed the follow-up question to this question in the comments, but the question was what type of battery chemistries will discharge hazardous materials? I know we covered that a little bit later in the slides, but if you want to speak to that for a moment.
Yeah, so there are some chemistries that actually will give off some toxic gases, and if they do, they're required to make sure that those toxic gases never reach above the PEL, and if they do reach at the level of the PEL, they're supposed to be exhausted out. They're supposed to have some sort of ventilation fans in there to actually remove that stuff so it never gets above the permissible exposure limits. So they are required to have some sort of ventilation and also to monitor them, obviously, to see when you get into the permissible exposure limits.
Okay, thank you, Paul. A couple questions regarding the 2020 New York State Fire Code and the New York City Fire Code. So first off, the 2020 New York City Fire Code defines a walk-in unit as a prefabricated building that contains an energy storage system. Is the intent to treat a walk-in unit as a building? Now, obviously, the code, as we know, does go into distinguishing walk-in units from a standalone building. But Paul, I don't know if you or Jen want to speak to that a bit more.
Yeah, that's a really good question. Came from a code official there because he probably looked at the 2018 International Fire Code. So that question was discussed back and forth in 855, where they wanted to include these things as buildings. But that is something that the AHJ is going to have to make the determination. Right now, it's in the International Fire Code. So usually the fire department will actually handle all this stuff for all those building inspectors. This is a question that you know what, let me get back to you before I give bad information. I will, if you write that down, Ian, I will actually get better guidance on that. Because I'm getting a little confused between the 2018 International Fire Code and the one that the New York State put out.
Yeah, no problem. I will make a note of that.
And just to be clear, New York City does not consider them to be buildings.
Okay.
Yeah, I can this is Jen. I can reiterate a little bit of what I touched on that. I'm not as familiar with the New York City specific fire code, more so the state fire code. But, and it was on one of the previous slides, I forget which number, but the outdoor walk-in units are treated as outdoor systems, so they have slightly fewer requirements than an indoor system would, provided that those walk-in units are below that volume threshold, which is approximately the size of a shipping container. If it's any bigger than that, then it is actually treated as an indoor system like it's a building.
Awesome. Thank you, Jen, for chiming in there. We'll go ahead on to the next question, which I do see is similar. So the 2020 New York State Fire Code defines two types of enclosures, one being a walk-in unit, the other being a cabinet. It's noted that fire suppression is not specifically required when installed outdoors in a cabinet. This appears to be true for both outdoor remote installations and outdoor near exposures. Is that the right read of the code? I think our understanding is yes, but we may, Paul, if you want to add any thoughts there.
Yeah, cabinets like you see in the picture here, they weren't required. The code officials looked at this. I mean, the committee looked at this and they said they're not required to have them on the exterior of that. There are some jurisdictions still requiring to have them on there, but the code does not require them to have it. When they are remote and also outdoors. Indoors is a different story.
All right, perfect. Thank you, Paul. Now this one, I answered it with the person who asked it, but I'll just reiterate for everyone else listening in. Question was, is 20 kilowatt hours the max for residential installations, even if it is a separated structure made specifically to house the system and at all proper distances? So for the residential installations, that 20 kilowatt hour threshold is going to be per unit, not aggregated. So for an accessory structure for a residential installation, the threshold aggregated is going to be 80 kilowatt hours. If you want to go larger than 80 kilowatt hours, it's going to then be subject to the fire code, not the residential code. Jen, I don't know if you or Paul have anything to add to that one, but I think that's pretty clear. There's a question.
I don't have anything to add.
All right, thanks, guys. There's a question. Jen mentioned that there were some that were considered hazardous because of their discharge. Paul, I think you already spoke to this as well regarding different chemistries. Will there be a collaboration with OFPC in regards to suppression and hazmat concerns for fire departments? We have begun some dialogue with OFPC, and we spoke with them regarding getting the word out about this webinar. So stay tuned on that front. We're definitely working on that and are interested in collaborating with them further. Now, is there any requirements for labeling of cabinets that hold these systems? Yes, there are signage requirements included in the Uniform Code. It's going to be section 608.11.8 for signage, and that is included for a number of types of installations, including enclosures containing energy storage systems like cabinets. There are also signage requirements in the National Electric Code. The next question would be for Jen and Paul. What are your thoughts on having on-site water supply via underground water tanks with dry hydrant connection for fire department pumper to charge dry pipe systems? Is there any type of cost versus benefit to having the on-site water supply? For context, it's a remote outdoor installation, 20 megawatt hours, no water supply available at installation.
So if there is no water supply, I'm assuming this is remote, right? I think you said that in the question.
Mm-hmm.
This is remote. As long as that we know that the separation distances between the enclosures, whether it's a cabinet style or a walk-in container, we know that there will not be any propagation. If the fire department could just bring their truck there without having that whole big thing, that whole amount of water stored there for a fire, I would feel comfortable with the fire department just bringing their tanker there. I don't know if you need to put all of that water in there. That's very big cost from what I understand. It all depends on whether you feel it's needed. I truly think that if the fire department just has their tanker and they have maybe a reserve tanker on top of it, if you don't have any water sources, you should be okay. What's the chances of you seeing more than one cabinet or container on fire? What do you think? Good, but I can never say never.
All right, thank you, Paul. So we have another question, sort of a consideration more than a question, but they're saying maybe the authority having jurisdiction can make a contingency of the permit approval that the permittee arranges that an annual training session is conducted by a subject matter expert with the local fire department, which can include procedures for maintaining valid contact means with the subject matter expert. I will just note that our model battery energy storage law, the one developed by NYSERDA, does include a requirement under our Tier 2 installations. So those are going to be the larger installations above the 600 megawatt hour threshold. As a part of our emergency operations plan, we recommend that you require applicants to provide procedures and schedules for conducting drills of these procedures and for training local first responders on the contents of the plan and appropriate response procedures. So we definitely agree that it's important to maintain some type of regimented training schedule, and we recommend that municipalities do consider implementing that as a part of their zoning law for these systems. So a couple more questions. I know these have continued to pour in, and we can do our best to get to a few more of these. From a code standpoint, is the structure safe to occupy, or does it need to be abandoned until the system is removed? So this is more from the incident management perspective. From a code standpoint, is the structure safe to occupy, or does it need to be abandoned until it is removed? Do occupants, assuming a residential installation, need to vacate?
Great question. That's a really, really good question. And I don't have an answer for it. I guess it really depends on how much we're on fire, if it can get out safely, can the residents get back in there, or the people get back in there. But it is a big question, things that the insurance companies are also looking at for indoor installations. I don't have a good answer to really answer that question.
Okay, thank you, Paul. Let's see, is there a link or reference on the gases generated during a large-scale fire test of lithium-ion batteries? Is there a way to look at, what type of off-gassing we're seeing from those fires?
Jennifer, do you have the NYSERDA Con Edison report?
Yeah, I was just going to chime in. I do have that. I don't have the exact location of it on the internet at the top of my mind right now, but I think we should be able to email everyone who attended tonight, and I can pass that along.
Okay, perfect. Thank you, Jen. Let's see here. Clarification on the remediation team topic from the beginning of the presentation. Is this team a hired third-party entity, not the fire department, or a team the owner needs to have on staff?
I don't think there's a requirement for the owner to have them on staff as employees, so I think they would have that option, or could potentially outsource to a third party, but it's not up to the fire department necessarily to provide that. Paul, I don't know if you want to add anything or clarify or correct me if you know different.
No, and that's the answer I would have given, is that it could be either the owner of the systems themselves, or they could hire out a third party. So this is kind of new within this sector. Being a firefighter myself, I really was big behind this when the committee had it up for discussion, and I was glad to see that it gave code officials that option to actually have that.
All right, thanks, guys. We got just a couple more questions coming in. Are we expecting environmental regulations to catch up with this technology / these technologies? Is there any consideration regarding protection and monitoring measures for sensitive settings, such as sole source aquifers, residents, adjacent streams, etc.?
I don't have a great answer for that, other than to say that before these systems are built, they would have to go through any applicable seeker regulations and studies before being built. So hopefully that would address it. But I don't have a specific response as to how exactly that will be done.
Mm-hmm.
I just want to kind of also build on that. Sometimes there may be areas that you're concerned about, runoff, and letting these fires burn sometimes may actually solve that. Now we have these flammable gases in there. So this is something that really has to be discussed more. And we are looking at that in the committee. But remember, that's an environmental place. So the EPA has not caught up with that. Well, I don't know if the DEC has actually caught up with it either for the city.
Mm-hmm. All right, thanks, guys. We've got two more questions. If you don't mind, we'll just run through those quickly. Thoughts on using gas detection for lithium-ion energy storage systems? This is going back to that 20 megawatt-hour example. That's an installation that's remote. It seems like it's 5 4 megawatt-hour containers. So thoughts on using gas detection for lithium-ion as an effective early detection means to catch thermal runaway early in its tracks. Do you recommend? Let's see. Yeah, so do we have thoughts on the use of gas detection as a way of stopping thermal runaway early on?
That for lithium-ion?
Mm-hmm. Yeah.
Any extra layer of protection reduces risk, so I don't have any bad thoughts to say about it, but anytime you add another layer of protection, you reduce the risk of an event taking place.
Okay, perfect. And then we'll go ahead to the last question that we've got here, and we'll close on this one. If the large-scale fire testing is used to justify exceeding the capacity levels or spacing within the code, does the installation have to match the fire protection installation used in the large-scale fire test?
F9540. So in other words, if can you just reread that question? I'm trying to find that.
Yeah, of course. No problem, Paul. So if the large-scale fire testing is used to justify exceeded capacity levels or spacing within the code, does the installation have to match the fire protection installation used in the large-scale testing?
Yeah, good question. So yeah, so the large scale testing 9548 is broken down to a couple of different phases. They start off with a cell phase, then they get into a module phase, and then they get into a rack phase. And then finally, the last phase is called the installation phase. And the installation phase dictates what type of fire protection is going to be used in order to control that fire. So if they're using a sprinkler system with a certain density, then that's what the density that's needed for the installation of that system. That's the density that they tested it with, so that's the density that's needed for that particular system itself.
Awesome. Well, Paul and Jen, obviously, thank you guys so much for presenting. And to all of our participants and attendees tonight, thank you guys so much for giving us a few hours of your Tuesday night. I hope that this was informative and relevant for you. Again, we will be posting the recorded webinar at some point here in the near future on our Clean Energy Siting Team website. That would be www.nyserda.ny.gov/siting. Please do feel free to check that out. We have our guidebooks available there. And again, thank you for your time this evening. Please stay tuned for any future offerings from our team. Hope you all stay safe and healthy, and have a great rest of your evening.